Hello, welcome back to Advent of Code. We are doing day 5 today. So let's go. You take the boat and find the gardener right where you were told he would be, managing a giant garden that looks more to you like a farm. A water source. Island is the water source. You point out that Snow Island isn't receiving any water. Oh, we had to stop the water because we ran out of sand to filter with. Can't make snow with dirty water. Don't worry, I'm sure we'll get more sand soon. We only turned off the water a few days, weeks. Oh no, his face sinks into a look of horrified realization. I've been so busy making sure everyone here has food that I completely forgot to check why we stopped getting more sand. There's a ferry leaving soon that is headed over in that direction. It's much faster than your boat. Could you please go check it out? You barely have time to agree to this request when he brings up another. While you wait for the ferry, maybe you can help us with our food production problem. The latest Island almanac just arrived, and we're having trouble making sense of it. The almanac, our puzzle input, lists all of the seeds that need to be planted. It also lists what type of soil to use with each kind of seed, what type of fertilizer to use with each kind of soil, what type of water to use with each kind of fertilizer, and so on. Every type of seed, soil, fertilizer, and so on is identified with a number, but numbers are reused by each category. That is, soil 1, 2, 3 and fertilizer 1, 2, 3 aren't necessarily related to each other. You see, this is why you want global unique identifiers. So here's our example. So our seeds. So we got 4 seeds there, each with a unique ID. Seed to soil map. Okay, so I'm guessing it's mapping one of these seed IDs to a soil ID. And so on. The almanac starts by listing which seeds need to be planted. Yep. The rest of the almanac contains a list of maps which describe how to convert numbers from a source category into numbers into a destination category. That is, the section that starts with seed to soil map describes how to convert a seed number, the source, to a soil number, the destination. This lets the gardener and his team know which soil to use with which seeds, which water to use with which fertilizer, and so on. Rather than list every source number and its corresponding destination number one by one, the maps describe entire ranges of numbers that can be converted. Each line within a map contains 3 numbers: the destination range start, the source range start, and the range length. The first line has a destination range start of 50, source range 98, and a range length of 2. Okay, makes sense. The second line, so each line is a range mapping, gotcha. The second line means the source range start 50 and contains 48 values because the length is 48, gotcha. So we're going to have to be very careful with off by one errors on this puzzle. Any source numbers that aren't mapped correspond to the same destination number. So seed number 10, which isn't in any of these 2 ranges, corresponds to soil number 10. So the entire list of seed numbers and their corresponding soil numbers look like this. With this map, you can look up the soil number required for each initial seed number. Okay. Let me continue reading. Okay, so the gardener and his team want to get started as soon as possible. So they'd like to know the closest location that needs a seed. Using these maps, find the lowest location number that corresponds to any of the initial seeds. To do this, you'll need to convert each seed number through other categories until you find its corresponding location number. In this example, the corresponding types are seed 79 to this, to this, to this, to this. So we sort of just need to filter these seeds through each of these maps until finally we're left with the location ID. Gotcha. Okay, so I did do this puzzle before Christmas. I have forgotten how I implemented it, so I am going to implement this again from scratch. I do remember part 1 wasn't too bad. Part 2 was a bit horrible, but we'll get spoilers. We'll do part 1 first. So what is the lowest location number that corresponds to any of the initial seed numbers? I do need my puzzle. I think I've already got my puzzle input set up. Day 5. So yes, they have these pretty big seed numbers here. And these pretty big ranges. Oh no, sorry, part 1 itself was a beast, I remember now. Okay, so let me explain. Let's go to this view here. So, if I come back to our input. So here they show pretty small numbers and pretty small ranges. So we could easily just iterate through each of these numbers, and then when we get to one of these ranges, we only have to iterate through a range of 2 to see if this number fits in this range. But we actually deal with very, very big numbers here. So we could still do this the naive way, and I'll implement it the naive way to begin with, I think, and then we'll see how that will fall apart in part 2. So I have my day 5 sort of set up, ready to go. So we're going to need to do our typical process. So day 5, and then we're going to iterate over each line. Let me drag this to the side. So, seeds. We might need to set up a little bit of a state machine to parse this, because it starts off with seeds and then the format changes somewhat. So it'll be something like try parser read skip word, and it'll be seeds, parser skip white space, and then we'll need some sort of loop. I don't know what the loop condition it's going to be yet, but we will do const seed ID equals try parser read number. I'm going to do a usize for this, and then we will I guess what we can do is parser is end, so while we're not at the end of the file, and then you know what, I'm going to put the skip white space here, so that way we'll skip white space and then we'll reach the end of the line like so. And we will need to put that somewhere. So this is our almanac, isn't it? So I'm going to do const almanac equals struct. This is going to have seeds. How many seeds? I don't know. We'll do a an ID array. And an ID array is just going to be a bounded array with view sizes and I'll do 64. There's definitely less than 64 there, I think. We'll have to do our usual init, so pub fn init, and it returns an almanac, and we'll do return seeds equals try ID array init with nothing by default. So let's put this here. We'll do var almanac equals almanac init. And then try almanac.seeds append, and we'll append the seed ID. So far so good. Then we're going to need to, so we aren't including empty lines, so actually the next line we iterate over is going to jump to this line 3 here. We're going to skip over this empty line 2, which I'm okay with. I think. Yeah, I'm okay with that. So we'll then do try parser skip word seed to soil map. We're going to have to we're not going to iterate over the next line. I think this will be if. I don't know if that will work. Let me just put in here almanac.seeds.len. I want to see how many, and let's zig build run that, see if it works. We got an error. Let's see why that broke. Error reached end. Reached end. Oh yeah, because we've passed this line. We're at the end, so this is only for a single line, of course. Let me just undo that for now. Day 5, 20. Okay, there's 20 seeds. I'm not going to count it to confirm, but I will check if, tell you what, I'll do almanac.seeds. Is it like the last? I guess it's pop. But I'll do get, which this will be the last one. We'll need to intcast that because we were doing new sizes. 367699984. That is definitely the last one. Okay. So that was just a sanity check. So this is working. So here we go. If line iter.next line and then again we'll do parser and then we'll do try parser skip word seed to soil map, and then we'll do here we want to do a while loop to iterate over these. So while line iter next line parser, skip white space, but because we only have white space in between and not at the end of the start, this needs to be sort of an optional skip white space. So we'll just do like a catch and do nothing, because this will throw an error if it can't find any white space. So just saying ignore the error if it can't find white space. And then we'll just do a const cata. Well, we have our destination ID. It's going to be try parser read number. And then we definitely want to skip white space. Actually, we can do it this way, can't we? Const our source ID equals try, and then skip white space again, and our range length equals and then we want to actually check here we go. If standard ASCII is digit, if the else will break. Yeah. If it's greater than 0 and the first character in the line is a digit, otherwise it's going to be a character, and then we will break out, and then we'll want to loop over this again. We probably want to put this into a function, but right now we need to let's call this an ID range, which is going to be a structure, and it will have a destination ID, a source ID, and I think it will be easy for us if I convert this length into a source ID end. And then we'll have an ID range array, which is a standard. You know what? Let's give it a category. This might be useful for when it comes to debugging. It'll just be a pointer to a const u8, so a sly. Yeah. Yep, that makes sense. And then yeah, we'll have a constant ID range array. Again, there's not that many of them. In fact, we could hard code rather than use a banded array. How many? Oh, but each of these will need to be one, so I'm just going to do, let's say 256 for now. I think there's 256 there. Yeah, this goes up to 211. That should be more than enough. And then we'll call these ranges. Map ranges. And that will be a you know what, I'm also going to give the category an ID, a numerical ID. And you'll see why now. So our category ID usize equals 1. Because we'll say the seed's category ID is 0. So the seed to soil would be ID 1. There we go. So we'll create a map range, which will just be a, tell you what, that can happen at the bottom here. Destination ID begin is destination ID. Source ID begin equals source ID, and source ID end equals source ID plus range len. But if I want the destination ID end, I'd also need, you know what, let's do range len and then pub fn is just self, which will be a pub fn destination ID and so we'll take a constant pointer to itself and we'll return self.destination ID begin plus self.range len. There you go, that makes more sense. So then it just becomes range len equals range len. And then we'll do the almanac dot map ranges append map range. I like it. I'll call these ID ranges. So this is an ID range. Okay, I think for this project, let me just do zig build. We're going to make use of a step-through debugger. going to make use of a step-through debugger. So I'm using a debugger called RemedyBG. This works pretty well with Zig. If you just search Google for RemedyBG, it's on Handmade Network or itch.io. So here it is on itch.io. It's about $30. And yeah, I like it because it's open. Well, it's not open source, but it is sort of. I much prefer it to like the Visual Studio debugger, and I haven't had much luck getting Visual Studio Code to work well, especially on Windows, to work well with debugging Zig. You can it does work, but hovering over, like when you use the cursor to hover over variables, that doesn't work to inspect them, whereas it does on RemedyBG. So we're just gonna go ahead and point it to our advent of code executable. The working directory needs to be the root directory of the project, and I'll just do advent of code 2023. There we go. And then if we go ahead and start debugging, that works. We will need to open the source file, so we'll go to source, day 5, and I'm just going to go ahead and put a breakpoint here. And now I can start to hover over my almanac and actually start to inspect it. So as you can see, I've got my ID ranges, and we've got a bunch of categories. If I look at the very last one in here, here's our seed to soil, category ID 1, destination begin is this number 39, it ends in 996. So if I come back to here and I come back to my seed to soil map, scroll down to the last one, we can see this ends in 996. So it looks like I've got all the correct data. In fact, I'm going to put in a almanac.id ranges. I'll watch here so I can actually look at that. And here is that, which is cool. So that is working quite nicely. Now what we just need to do is continue for the soil to fertilizer, fertilizer to water. So before I roll this into a kind of a loop, I'm just going to do another case here. So I'll do, okay. We don't want to do line it to not next because by the time we figured out we're here, if we do line it to dot next, we're going to get to here, and we want to do this. So here's my plan. I'm going to do up at the top, I'm going to do const categories. So it's going to be an array of strings, because this bit here, a const slice of U8, this is a string, and this is saying an array of strings, and this is going to infer the number of elements in that array. So it will be seed to soil map, and then soil to fertilizer map. You know what, I'm gonna Yeah, that's fine. And then it'll be a fertilizer to water map. Water to light map. Light to temperature map. Temperature to humidity. And then finally, humidity to location. Here are categories. I'm going to make this, seeing as it's like a global define. So while line iterator dot next. Here we go. So if standard.ascii is alphabetic, I'm going to reorganize this. I'm going to say category ID starts off at 0 now. Get rid of this category name. I will put the parser up here. Then we'll say okay. Const categories, category ID. There we go. This is a compile time string concatenation, because we know this at compile time, and obviously this is a constant string here, so this should work. And then we can do this. And then we'll do plus equals 1. Else if standard ASCII is digit. And then I'm gonna go ahead and hoist you up here. So we can get rid of this. I'm going to call this next category ID, and then our current category ID and current category name. We'll say that's undefined, and so our current category ID equals next category ID, and our current category name equals this. And then we'll increment next. Tell you what. There we go. And then this becomes current category name and current category ID. I think that makes sense. Else we'll break. Actually, we should never reach a case where it's either not alphabetic or digit, so I'm going to return error invalid puzzle input. There we go. So let's go ahead and build that. What's unable to resolve comp time value? I guess actually this wouldn't be comp time known because of that. But that's okay. We can do it's standard.format. I'll do an alloc print. The format will just be this, and the args will be current category name. So this will be the map title. We'll try this, and then we'll defer allocator free map title. So we will be, tell you what, I'll call this the map title buffer. This will be a slightly quicker way of doing it. So titles now are going to get longer than like 25, 32. So I'll just do 64 U8. And then this becomes a buff print. That title buffer. Then we don't need to free it. And we're not allocating too much. Let's give that a go. And let's run it. Oh, what was the output there? Didn't like it. Let me run it here. We're getting an invalid skip word. It would be nice if when this throws an error, it set a breakpoint. Let's give this a go. So what's our map title? Seed to soil map. Oh yeah. Get rid of the map. Pull that out. And run it. So our map tile, seed to soil map. Continue. We need to continue all the way to here. Hey, so we can have a look at our ranges. We should have quite a lot. So we got seed to soil, seed to fertilizer, water light, light to temperature, all the way to humidity to location. So if I look at the last humidity to location one, our range len, I'm going to copy you and just put you down here. Range len, and that is the same number, so it's definitely the correct value. So we've successfully passed the puzzle input. That's always just the first hurdle of any challenges, passing this text input into some useful data structure that we can now work with. So we have our seeds, our ID ranges. So we probably just need to, all we need is like a function that does get destination ID from source ID. right? Source ID will be usize. I'm just going to reduce the font size down a little bit. Shove you over there. So to get destination ID from source ID, we might not even need these two functions. These might have been premature because our destination end ID is this, source end ID, self.source ID. We're pointing the end ID and then if our source ID is greater than or equal to our self.source ID begin and our source ID is less than source ID end, then we want to get the source ID's offset. So const source ID offset is equal to the source ID minus the source ID begin. And then we just return self.destination ID begin plus the source ID offset, right? Otherwise, we just return the source ID. It just sort of falls through if it's not in that range. So we don't actually even use destination ID end. So these two functions can probably go. Get destination ID from source ID. We don't need the get, that's obvious. Destination ID from source ID. You know what, actually, I'd rather this be return an optional number. So if it's not in the range, I'm just going to return nothing. I think that's going to be more useful. Then in the almanac, we can have a function which will be this same thing, but we'll also have a category. So first of all, it will take a const pointer to the almanac, the source ID, which will be a usize, but also a category ID, usize. And this will return a non-optional number. And then basically we'll do for self.id ranges, ID range. If ID range category, this has to be a const slice to be able to iterate over it, does not equal the category ID, then we will just continue. Var result ID usize will equal the source ID to begin with, and then we'll do if ID range dot source ID, destination ID, then we'll just set the result ID to be equal to the destination ID, and then return the result ID. So that's going to loop over all these ID ranges, skip over the ones that aren't our category ID. Actually, as soon as we find a hit, we can just return it. Otherwise, we will just return the source ID. And we don't need this intermediate variable. I think that works. I probably want to try this out on our test to just have some more reasonable numbers. So let me get this to be our test. Here we go. I'm gonna load in test. So if we do for almanac seeds seed ID, if I do almanac destination from source will be the seed ID and the category will be the first category. So this will be the soil ID, right? I'm gonna just print that soil ID. And zig build run. Oh, this is still running. Let me stop our debugger so we can write to that file. So here's our 4 soil IDs. Let me just plonk them in there. 81, 14, 57, 13. So seed number 79 corresponds to soil number 81, 14 to 14, 57, 13. So that's working. And then if I do day 5, it's going to do the same here. These are all our soil IDs. So we should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yeah. Okay. Now that we've done that, basically we need to get the soil ID, and then we need to now go through each of these steps. So we could do it like, okay, fertilizer ID equals almanac, soil ID 1, and so on and so on. And then it'll be the water ID, which will be the fertilizer ID 2. So what we can do then is we'll say, okay, var ID usize equals seed ID, right? 402 next category ID. We'll do our destination ID is equal to our ID and our category ID. Well, we don't even need to do that, we just pass that through. And then our location ID would be this. We can do like, okay, soil ID into location ID. Oh no, sorry, seed, not soil. Does that work? So there we go, we've got those. And now we just need to find, okay, what's the lowest or smallest location? And that's pretty easy. So we'll do var lowest location ID usize. So we'll start with the maximum here. Then we'll say, okay, if, just to be clear, we'll say, okay, location ID equals ID. Okay, so if location ID is lower than the lowest location ID, we'll do the same for lowest seed ID. Then the lowest location ID is the location ID, and the lowest seed ID is the seed ID. And then we can print that at the end. Lowest seed ID, lowest location ID. And we'll zig build and run that. And so we've got this here. Let me just create a like that. Okay. 515-AT674. And does that map to the answer that we gave, 515-AT674? Okay. So far so good. We have solved part one of the problem. Okay, so before we continue, what we are missing now is some way to visualize this. I think visualizing this would help quite a bit. The only problem is these ranges are really large. So I want to find what's the largest ID that we've got here. So I'm actually going to compute that. So this is compute the lowest location ID. This is parse seed IDs, parse category maps. There we go. And then I'm going to do compute the highest ID. and I'll do, okay, for almanac dot ID ranges, ID range, var highest ID, we'll start with 0. We'll do dest and equals ID range dot destination ID begin plus ID range dot rangelen. Is that right? Destination ID begin and const source and equals ID range dot source ID begin plus ID range rangelen. If dest end is greater than highest ID, if source end is greater than highest ID, and the highest ID equals source end. And then I want to debug print that. So here's our highest ID, and I think this is going to be quite useful. So we actually want to store this highest ID in our almanac. So we no longer need that. Because we'll use that to scale whatever we are rendering. So our solution now needs an almanac. Almanac. Just going to have a pointer, which means we probably want to allocate this. So var almanac is going to be try allocator dot create almanac, and then we'll do almanac dot init. Almanac. This will return nothing because it will just be self equals this. This will init it. And then here we go, the answer. Almanac equals almanac. So to draw, I want to draw let's try and draw this first range. So I'll just call this const ID range equals self.almanac ID ranges get 0, right? And so I want const x start or x begin to be the ID range dot source ID begin and I want to do float from int, so this is going to be a float 32. If I divide this by the self.almanac.highest ID, give us a number from times raylib.screen width. And our x end will be, so this is where we actually do want those functions. So pub fn source id and self const id range return self dot source id begin plus self dot range len. So this will be, there you go. And then I'll do C, well, what's the function? And let me also just quit that out. And we want to draw a line. Here we go. So actually, it does want an int. So we could do int cast. Yeah, it wants a cint. Uh, 10 x and 10, and let's just do c dot red. So you do have a known, I don't know why you're arguing about that. I would have thought the compiler could infer, because I put C in here. Apparently not. So I can't see it on screen. Let's just make sure if I do raylib dot screen width, we can actually see it. Yes. So it's possible that this is just going to be really small compared to everything. I mean, the lowest ID is 0. Tell you what, I do want it as a float. If I do F, is that for float? Don't draw the line. See what happens there. Oh, we want float from int. Yeah, I think this has to be D. DD. So we're getting 0, 0, 0. Alright, float from int ID range source ID begin ID end f32 float from int source ID end, and then const ID width. Unless I've got this the wrong way around. That just gives you 1, 1. So yeah. Okay, that's giving me more interesting stuff. So x begin f82 is just going to be ID begin divided by ID width, and x end going to be ID end divided by ID width. And if I do that, that should now draw the correct line. Seeing, and then this needs to be cast back into an integer. Or we just use the one that takes in a vector. And thickness. I prefer that one. Const so then I can just do that. Don't need this, and then this just becomes line start, line end. Thickness can be 2, and color C.red. Oh, get rid of that. Put the semicolon in the right place. Okay. Still can't see it because probably the length of that line, if we print that, which which is just going to be line end dot x minus line begin dot x. It's going to be really small, maybe. Use the same naming scheme, Luke. Yeah, it's just really small. So these are getting truncated to the same pixel. Okay, welcome back. I had to do some faffing around to draw. I basically wanted to draw these ranges on screen, and I messed around and I basically forgot to multiply my computations by the width of the screen. So what I'm doing here is I'm looping through our ID ranges, and I'm just getting those ID ranges, source ID begin, source ID end, and then dividing it by the highest ID, so I know like the full scale, to get sort of a normalized number from 0 to 1. And then if I multiply it by the screen width, I can now sort of show each of these ranges across the screen width. So what I sort of want to do is also do, so at the moment I'm only doing the source ID begin. So I will do source ID, so ID width goes there. I also want the dest ID. So this will be an F32 float from int. This will be ID range dot destination ID begin, and const dest ID end F32 float from int will be the ID range destination ID end, and this will be a function because we'll compute that on the fly. So let's scroll up to here. Destination ID end, and that's just self.source, sorry, destination ID begin plus the range lem. So we can do the source line begin and the source line end. This will be in green. Okay, that's the source ID begin and the source ID end. And then let's move these down. And then our dest line begin will be our vector 2, and the x is going to be equal to the dest ID begin divided by the ID width times raylib not screen width. Y is going to equal to let's just do like const line width or line thickness. I'm going to say 2 line thickness. So we'll do 13 plus y. Let me also do end. And then we'll draw that line, maybe in blue. So that's our this would be our line thickness. Tell you what, there you go. Plus line thickness, say times 2. plus y. And then we won't do the 10 because we can do that in our offset thing. So we'll do raylib begin offset 2D 10. There we go. So here's all our ranges. I want to do a raylib.clear. I've forgotten how you do a clear. I think I've got an example of it in main. Clear background. We're just going to do pure black for now. That is not working. Oh, why? That usually works. Okay. The gradient's still there, which is interesting. Sorry. And then we will also draw two baselines. X is going to equal to 0, dot y is going to equal to y. It's going to be equal to raylib.screen width, and this is going to be white. And then our baseline here, our y is going to be equal to this. Then we can actually use, okay, baseline 0 begin dot y. We can reuse that information. I actually want this to be the half thickness. Or just give me one. And then the spacing, we can make that bigger or smaller spacing. say inner spacing and const outer spacing. So this will be the outer spacing. The inner spacing is this, actually. So I want the outer spacing to be larger, say 12. And the inner spacing to be larger as well. So let's actually do something like this. Oh, that needs to be white as well. There we go. And then I want to loop over all of the things. So this would be self.almanac ID ranges, const slice. So this would be the category ID. Or, okay, ID range. And then we can say, okay, const category ID equals 0. So we got the ID range, and we can say, okay, if ID range category ID does not equal that, then we will continue. Index, and then we can do like a bar index size equals 0. Index plus equals 1. So this is all the seed to soil. So actually, if we do outer spacing 0, I'm trying to see different ways we can visualize this. So you can actually, from this, we can see that none of the input ranges overlap, I don't think. Now here's the interesting thing, if I can hover over, so if I can get the mouse then we'll say, okay, Here's our source ID, line begin, line end. And we'll say, okay, if mouse.x is greater than or equal to source line begin.x, and there might even be helper functions in Raylib for this. Checks if a point belongs to the line. Yeah. So this point is the mouse pass. Point is source line begin, source line end, and then say the threshold, we'll do like 3 pixel threshold. And then we can do const source color equals if we're on line c.orange else c.green. We will need to Raylib. Because we got this offset, we'll create a new function called pov mouse position, which will turn a vector to so our absolute mouse pass equals c get mouse position, and then we will return .x equals our absolute mouse pass .x minus our current cam .offset .x. There we go, we need to do that, so that becomes Raylib.mouse position. So now we can hover over these lines. So actually, yeah, I'm going to do the outer spacing to be 0. Whoop. So now we can see each of these ranges, which is nice. And we'll do the same here, so const dest color, otherwise it's blue. Or how about purple? Or red, I like red. So now you can see how these range nice. Shall we increase the thickness? and the inner spacing. So if I do, let's say 25, and let's say 8. That's nice. And then I also want to draw if is online. I want to draw 2 lines going from the source to the destination. So that would be let's make them white. It'll all be 1 pixel. It'll be from the source line begin to the des line begin, and from the source line and to des line and actually no, I want them orange. There you go. And now I want to go through and draw the categories. So this would be, okay, for categories, category name, category ID, we will do draw text. Can I do that? So that can go. I'm just gonna comment this out for now. Yeah, okay. Or we'll just say, okay, 99. Continue. Okay, so we'll use our raylib function, which is raylib this then has to be a int from float. Outer spacing now becomes, say, 50. Very good. Let's do 100. So we got seed to soil, soil to fertilizer, fertilizer to water, water to light, all the way to location. I'm actually going to plot this down to 80. And then for each of those categories, we will loop. So this goes into here. our baselines we only need to draw once, right? Let's make sure that works. Yeah. So this needs an offset. I'm going to say 20. There we go. So it's not a magic number. And then here we go. And then we'll go through all of these. If it's our category ID, then we will draw them. There we go. And then these orange lines, we will actually have to loop over them a second time. It's not... Basically, we want to defer the drawing of these lines. So we can do that. We can do that just fine. Const we'll call that a line segment, and it will have a begin, which is going to be a c dot vector 2d, and an end. There we go. So we will do actually we only need to do this. This doesn't have to be an array. It just has to be the highlight line highlight source ID begin, which will be a c vector 2, which is going to equal null. We need 4 of them. Begin, and begin, and this is our test. Get rid of these IDs. There you go. Then we'll draw. And we need to unwrap these because they are optionals. But we know this is safe to do because once this is not null, the rest are not null. There we go, that's drawing properly. I might increase the threshold if I double it. And then we can always do the reverse, but I'm happy with this for now. As in, or oh, it works in reverse as well, which is nice. So then what we want to do is I want to from all of this offset it down even more. So I'm going to offset that, the outer spacing. So I've got room for my seeds at the top. So we're not using this index. So we can do for self.almanac seeds. This will be seed ID and the seed index. We kind of need to do the same thing here. Where the ID width, but we can hoist this ID width out. We don't need to compute that every time. This is the seed ID begin. So this will be seed ID, seed ID, and so for now I'm just going to add a, because I want to be able to click on the seed. So let's say, I don't know, 9,000. It's going to be whatever Y is, which at the moment, seed ID and then we'll draw that. So seed line and seed line begin. We'll make that line thickness. Let's do yellow. At the moment we're not using seed index. In fact, let's just get rid of that. Yeah, these may need to be, these numbers get really big, don't they? $9 million. Is that going to be too wide? So here's our seeds. Okay, I want to do seeds. And then I actually want to draw all of this, draw the seeds bit after everything else, because we're going to display information over. So what we'll do is we'll do the is online thing again. We only need this for now. So it's mouse pass, it's seed line begin and seed line end. We'll do, say 10 for now. Is on seed, and then we'll say, okay, well, we're using orange as a highlight color, weren't we? So there's actually quite a few close seeds here. And then if we are on seed, we are then going to draw lines from the seed to the corresponding. So we kind of need to redo this. Okay, we don't no longer need that. no longer need that. Oh, by the way, the answer is the lowest location ID. We will need that. But yeah, this sort of here, we'll do this loop. So it'll be var next category ID equals zero. Oh. We can just use that. So we look over the self, the almanac.category count. We don't need that anymore. ID, category ID. So now we have so we want to draw a line begin and end. So we want to draw a line from the seed. So we're just going to do one for now. From the seed, which is going to be seed line begin.x. I could have just done seed line, okay. Y, yeah, that's correct. But then the end is going to be basically this. Which will be the outer spacing. Okay, we're gonna, that's outer spacing. Let's have a look. Line Y offset. These baseline. So I probably need to extract this into a function. So this will be get baseline of category, and it will return a vector 2. it will actually return a structure, beginning and end. This Y I'm going to push these out. Yeah, I'm going to do actually no, that'll be the source begin and the source end. C dot vector 2 and then the dest begin and the dest end C dot vector 2. So this will be get baselines for category. This will return that baselines. So we got source begin, source end. We also need these two. This is dest begin and dest end. There we go. So this becomes const baselines category ID. There you go. We no longer need these. Because this is baselines.source begin. Dest begin, dest end. This becomes baselines source begin dot y. There you go, and then we'll do the same. So if we're on seed, we need the const baselines. Oh, actually, we need it in the loop. Category ID. And the end will be baselines source begin.x. Let that build. Although this is still working, but this is not. Why? Oh, dot y, not dot x. There we go. So that's now pointing to that. I then want to draw a line continuing from here to the corresponding destination, which then draws another line down and so on. So we will get like a nice little filter look. So this will be our line to source. And then we want to dest. So we already know what the x is. It's source begin.x dot y spaceline source begin.y, and then to dest end, well, it's going to be, but the x we're going to have to calculate. And to calculate that, I think this should be a function. Get screenX for ID. Right, so we'll do ID, which is a usize. We'll do the ID width, which is going to be an F32, and it's going to return an F32. And then multiplied by raylib.screenWidth. So then this just becomes get screenX ID range destination ID begin ID width, which means we don't need that. It's not used anywhere else. There we go. So we'll refactor that. These are now unused, which is nice. We can do the same thing here. So get screenX ID. So this will be seed ID. And then we'll do the same here. Just seed ID plus the 9 million. There we go. And then we'll do the same thing here. So it's going to be get screenX, and the ID is going to be this. So this ID now needs to go here. It's just going to be ID and ID width. So again, we're only doing one. It's not quite working. Because our toDest begin needs to be prev ID equals ID. Yeah, okay. Get screenX, so that's previous ID, ID width. So that's now mapping these like so. Then if I don't break, does this work? Not quite. So that's going to that. Which then goes to that. You know, like if we put previous ID up here, then it's this. Previous ID X is going to equal to this. We only need to compute that once. So that's going, so it'll always be straight down like that. But then we don't always want to be from seed line Y. We want to be so if it's 0, then it'll be seed line and I mean it doesn't really matter. Else it'll be tell you what. If it's greater than 0, then we'll do const prev baselines equals -1, begin y will equal prev baselines dot test begin y, and that goes to begin y. We can actually make this const by doing like a block. Like that. There we go. And now it's actually mapping it throughout the whole system, which is pretty cool. And so from this we could probably work out, okay, what's just visually what's the lowest location. As it stands, it's one of the very early ones. Is it just the first one? Or what does the answer say? Oh, I need to put into the answer not the lowest location but the lowest seed. Hang on, what does the website ask for? What is the lowest location number that corresponds to any of the initial, lowest location ID? So the lowest location ID is 515. I mean, what I could do is, after all that's printed, I'll do raylib draw text alloc print allocator, the format. Oh, I don't need to try that. Let me do raylib.screen height -40. So it will print out at the bottom of the screen. There you go. And it literally is just the first 515 at 8674. The first seed corresponds to the lowest, which is kind of funny. But I think now that I have this visualized, we are prepared to go on to part 2, which is here. So let's get ready.